Oh, can you let me share the screen for
I don't know.
you got that, Corey?
Yep, I can see it.
So I'm just going to quickly show them the process, Andrew.
Yep.
What's on the screen is the design pH model. Oops, that's not what I want.
Yep. I can see that okay, actually.
Yeah, all right.
Yeah, I've just got to be a bit slower because I've got to move things around a bit more. That's all.
Sure.
It'd be better if I did it in landscape, actually. So I'll try and. Oh, no, it's not.
Yes, everything I've got is in landscape. So.
Yeah. Soldier on. It's not working on a landscape, but anyhow.
So the red is the building envelope,
Yep.
which is what we're measuring, and everything else is shading element.
Okay.
And then, so we run the analysis, which gives us a wintertime result, but not a totally accurate one. Basically, we just use this for the geometry of the place, and then we put all the information in. We just use default settings, and then we put all the information in PHPP.
Yep. Okay.
Which is this. I will make it bigger. That way you probably.
No, I can see that. Okay.
Yeah.
Because I'm zooming it in.
Okay.
I can read that all quite okay.
So our heating demand is 11 kilowatt hours per metre squared per annum. The criteria is 15, so we meet that.
Yep.
Our cooling and dehumidification is 10 kilowatt hours per metre squared per annum. Criteria is 16. Since when? That's meant to be 15. Anyway. So we meet that. We are not overboard with humidity.
Yep.
So that's 8 grams per kilogram, and the criteria is 10.
Oh, yeah.
And our PER, which is primary energy renewable, which is a bit of a complex thing. In short, it relates to the amount of energy that's generated at the power plant.
Yep.
Well, actually, not the power plant. In terms of renewable generation to drive your house.
Okay. Yeah, I was going to say if it's PER, I would have thought because if you're getting solar on, you just got to look at what generation value, not necessarily.
Yeah. So I haven't put any solar on at this point in time.
Yeah.
When we put solar on, that number will go down.
Yeah. Okay.
So that's excluding solar.
Yep.
So the climate data at the moment we're using is Richmond.
Yeah, fair enough.
So there's a couple of options. We've got Richmond, which is close in altitude, and we've got Springwood that's close in terms of location.
Yeah, proximity.
Proximity. So it'll be up to the Passive House certifier to decide which one.
Oh, right, okay. I reckon you probably should go with Richmond, really.
Well, that's what he said to do to start with.
That makes sense anyway.
Yeah, Richmond's fairly extreme is the only thing.
Yeah, that's true. With the heat-wise, it is, yeah. But
yeah, well, even cold, like Richmond gets to minus, in overnight in winter.
Mm-hmm.
Interestingly, so we've got 11 and 10. When I change the climate to Springwood, our cooling and heating demand goes up.
Yeah.
Now, I would have thought it would have been the opposite. So, yeah. So we might be better off with Richmond anyway.
Yeah.
I mean, obviously, in reality, it's not going to change. It's just in terms of measurement. Yeah.
Yeah.
So all the walls at the moment I've got in are Timbus 140 mil stud frame walls.
Yep.
with 140 mil R4 insulation.
Yep.
Floors, concrete with XPS insulation on top.
Yep.
And the roof or the ceiling, I should say, is with R6 in total.
Yep.
So what I've put in there is, so we're going to have 90 mil ceiling joists.
Yep.
So I've put R2 wall bats in there because you can't get R2 ceiling bats. And then I've put R4 ceiling bats on top of that.
Right.
And the reason I'm
just quickly, Mark, what is an R4 and what does R2 mean?
So, okay, R is the resistance level. It's the insulation number we use, basically.
Yep. Okay.
So the higher the number, the better it is.
Yeah. Okay. Yeah. Oh, I sort of anticipated that. Yeah.
Yeah. There is another measure that we actually use in Passive House, which is the U value, and it's the opposite. Well, it's actually the inverse of the R value. Okay. And the lower it is, the better. So you can see here.
Right.
So this is your ceiling assembly.
Yeah.
I've put everything in.
Mm-hmm.
So we've got the cavity, and I'll put that in as 200 mil because that's what I've been told in terms of your dehumidification. And then you've got 10 mil plasterboard, which gives us a U value for the whole system of 0.163, which is pretty low. Okay. So yeah, the U value, the lower the better. The R value, the higher the better.
Yep.
The reason I've got the two layers of insulation is because if you have one layer of insulation between your ceiling joists, then there's nothing above your ceiling joists.
Yeah.
An alternative there is, if we can fit it, there's some new bats on the market that are R7 or R8, and they're deliberately wider, so they will squeeze between the ceiling joists, and then they will, above that, they will come together and cover that gap.
Right. Okay. Yeah.
Now, in a traditional construction, that's a good idea because if you need to get up on the roof and do anything, you can see where the ceiling joists are.
Yeah, and that'd certainly be the case with myself, being the Sparky I am.
Yeah, but see, what we're going to do is run all your services through the ceiling cavity.
Yeah.
So that 200 mil service cavity, that's so going from the top down, you've got your R4 bat, got your R2 bat, then you've got your airtight layer underneath that.
Yep.
So underneath your ceiling joists, then you've got your service cavity.
Yeah.
And then you've got your plasterboard.
Plasterboard.
I use 13, don't you, Corey?
Yeah.
Okay.
So yes, so because all your services are in your service cavity, we don't have to be so concerned about what I just said up top. Now the calculation takes into account the timber. So the timber is a thermal bridge. So we've got the R2 wall bat. We've got the 90 mil timber ceiling joists, and we'll put them as 15% of the entire area. So that reduces our effectiveness, but we need to account for it.
All right. Just got a quick question, Mark.
Yeah.
When you come from your main distribution board, I'm talking from the electrical engineer or Sparky's view perspective now. When you come from your main distribution board, and you're going to come up your walls and that, and through the ceiling and that, and through penetration, and you've got to penetrate through into those areas and so forth. What are we got to do with penetration?
So the idea is you'll have one penetration for each service.
Okay. Yep.
And then everything will travel, or minimum number of penetrations, and then you've got a wall service cavity and you've got a ceiling service cavity.
Yep.
And so you run everything there.
And do we seal them?
Yes. So where you penetrate will be sealed off with tapes, or gaskets, or glue, or all three.
Can you use like the foam stuff, or?
No, we generally use There's a number of products on the market ProClimate have put out which are designed to do this. So,
Yeah. Okay.
so
Fair
you
enough.
basically each circuit will have a penetration.
Yeah.
But that's it.
Okay. Yeah. Fair
So
enough.
if you've got 5 circuits, you'll have 5 penetrations.
Yep. Okay.
And you can potentially bring them through in the one spot. Although
Yeah. Yeah.
it's
Well,
probably best practice not to do that.
yeah. But these are the sort of things I've got to thrash out now because I've got to design my circuitry for that, for going upstairs and that and going through the house. I've got to know these things. Yeah. Yeah.
Yeah. So what I'll do is I've got a link I think I can send you, which should show you sort of one of the main methods of doing it.
Yeah. Okay. Yeah. All
So
right.
basically, what you do is you put a small hole in your membranes, and then you put tape, sort of folded up from the membrane onto the cable.
Okay. Yep.
Because the cable's flat, it sort of whites in quite well.
Yeah. 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 It's 2. Yes. Yeah. 2.5. Going upstairs would be no bigger than say 2.5 mil 3/4 cable going up there.
Yeah, that's right. And it doesn't matter even if you've got the thicker one; it works the same.
Yep. Yep. All good.
So yeah, there's your wall build up. So you've got your R4 in the timber frame, your 45 mil cavity, which is your service cavity, and then your 13 mil plasterboard.
Yep.
It's 45 mils to allow for a lagged hot water pipe.
Yep.
And it also gives you plenty of depth for your power points and your light switches and everything.
Yeah. Okay. Good.
Now your floor. So you've got the concrete on ground. So the concrete slab I'll put in as a 120 mil slab. 50 mils of a very specific XPS foam. Fibre cement sheet board and then your tiles. And
the reason for the fibre cement board, remember, was what Harley mentioned, that when you want to retile in 20 years or 30 years, you don't have to pull the insulation out.
Yeah. Okay. Yep.
And don't know why I've got in there. So this is each wall and each floor and each ceiling. The ceilings are called roofs. Your area, which direction it's facing, the emissivity of the material, the absorptivity of the material. Can't say that. Now this is where I want the certifier to double check everything, obviously, but in particular, thermal bridges. So thermal bridges, any change of direction or any change of material.
Yeah.
So for example, the area around your slab, where the wall meets the slab is a thermal bridge, where your eaves are is a thermal bridge, your the corners of your walls where they meet, etc. And the thermal bridges are a little bit complex. With all the different floors, some suspended, some slab on ground, etc. So, I certainly want the certifier's input for that. Because we're basically, this ground sheet is where we calculate each of those slabs, and we've got 3 different ones.
Okay. Yep.
So, yeah, I did discuss this with the certifier a bit, and when he learned that there was 3, he went, "Oh my God, you've complicated things here." So thanks, Corey. Just on the thermal bridges, Corey, do you know how you're going to build that curved wall downstairs?
I've since looked at it and deleted it. I think
it's
worth it. I think
you did. Yeah.
Just
okay. Well, that's good. I'll have to update them, pull that out.
Yeah. Because I was thinking, because Andrew, the discussion Mark and I had was, do we make the little section of floor above that access into the garage doorway out of timber because it's a huge thermal bridge? And I just thought, let's just simplify it, get rid of the curve, get rid of the
Yeah.
access, and then you can just
Yep.
have the slab come across to the wall, and it's a lot
Yeah.
easier. Don't have to do tricky stuff.
Yep, agree. That's
So
fair enough.
when you give me new drawings, Corey, I'll need that obviously in the drawings.
Can I just ask the question again, Mark, on the slab thickness? The structural engineer had the suspended slab over the garage at 200 and the slab
200?
upgrade at 170. Is that a huge?
No, that's not a problem from my perspective. It's only going to improve things slightly.
Improves it, doesn't it? Yeah, because it's
So concrete on ground was 170, is that right?
Yeah.
Basement, garage slab. Well, I don't even know why I've got that in there. I'm probably not using that. Garage ceiling, it's called. I've forgotten to put that one in actually. Concrete on ground, next piece. Longer. Okay. So it's going to be tile.
seaboard.
Fiber. Shape. And 150, 130. So 200.
Yeah.
Hasn't changed anything. It's pretty similar build up anyway. So Okay. Windows are all in the Logic House windows.
Yep.
So we have to assign to the different types. So we've got outswing doors, lift and slide,
Yep.
opening window, fixed window. So they're all assigned from the schedule. There's a few different glazing units to match the different, for example, the lift and slide is a 54 mil unit. Everything else is 44 mil unit. So that's all in there. So I run 2 of the design pH models because we've got a deciduous tree there. I run one with the leaves, one without. And this is the result for the shading. So there's for winter, for summer. And if we put any additional shading in, like external blinds or that sort of thing, we put that in here. In terms of the model, we don't need to do that.
Okay. Yep.
The ventilation unit, we haven't. Oh, I thought we had selected that.
Yeah. Yeah, Scott's in that through.
I mustn't have saved this when we talked. HRV. Anthem HCV 400. Oh, hold on. Wrong spot. Yeah, that's improved our heating demand a bit.
Right.
It's a better unit than the default unit, basically.
Okay.
So we've got the ducting in for, this is the ducting between the unit and the outside. And I've got 4 meters of ducting from the unit to the outside. That makes a considerable difference to the efficiency. So if it's any less or more than that, that will change things.
Is that the
We've got plenty.
HRV mark? It's 4 meters.
Yes. So the big ducting
Yeah.
from the HRV to the outside.
From the HRV unit to outside?
To outside.
It's on the external wall. Why is it 4 meters?
Because I didn't know that.
Okay.
So I'll put in 2 meters.
It'll be like 300 mil.
Let's leave it like that for now.
Sure.
Better to be conservative.
Yeah. Okay.
And don't forget, well, it depends on what vent he's using. So normally you have 1.5 meters between the supply and exhaust vents. However, you can get a combined one, which would probably work in your design. So they don't work very well if it's in a courtyard or something.
I'll have a look. He sent me through everything. Exhaust valve, did you say?
Next up, all installation exclusions. I'm just looking at the quote. It looks like he's got separate ones, I'd say.
Okay.
So yeah, so 2 meters is probably right for one of them. Now,
sorry, can I just go back to Windows for Andrew?
Yep.
Andrew, were you still, Emery, still keen to have a look at some of the Logic House windows installed?
Yes. Yeah. Yeah. Would. Yeah.
And I think you said you wanted just a white internal finish paint.
That's right, we did.
So did you talk to Harley yourself about that? I can do
No,
it.
I didn't. I thought I just responded to an email. Did I not?
I'll follow up with him and just.
Yeah, I'll check at my end. I may not have sent the email, but I thought I'd got that through. Yeah.
Okay. Sorry, Mark.
No, that's right. Now, so this is for now, this is the ventilation sheet with that detail. What's going to have to happen, it gets a bit more complex. Once I know what range hood you've got, I need to put that in.
Okay.
And we need to account for that. So what will happen is we will lose about 1 to 2, usually between 1 and 2 kilowatt hours per meter squared per annum. So this might go up to 11, 11.5 or something.
A range would impacts it that much, does it?
Yeah. We've got to account for the range hood sucking out warmth and coolth. Yeah. The only time it doesn't affect it is if we have a recirculating range hood, and I wouldn't recommend that because they're not as effective.
Fair enough.
The building code doesn't allow recirculating range hoods anymore. You can use them with the performance solution. So I've got a project under construction in Blackheath where there was some big gum trees blocking off winter sun. So we were right on the edge in terms of our heating demand. So if I had a ducted range, it would have put us over. So we've had to go for recirculating there and a performance solution. But yeah, that's not ideal. So,
Okay.
yeah. So once I know the unit you're going to use, then I'll put all that in here.
Okay.
So I probably could have put a temporary unit in, I suppose. But anyway, so but like we've got plenty of room to move there, so it's not an issue. This is just
products with that.
Sorry?
What's some of the products you could look at, Mark?
Oh, just whatever range hood you want.
Yeah.
Obviously, the more powerful the range hood, the more heat loss.
Of course, yeah. But I've got a couple out of against, what's the area, what's the footprint that I'm going to need to be sucking out of the kitchen, all right, and slightly larger than the footprint, I suppose, just to ensure you've got it covered.
One thing, I don't know if you're aware of this with your background, Andrew, but any extraction fan needs make-up air to work. In a passive house, because it's airtight, there's nowhere for it to get that make-up air.
Okay.
So there's a couple of options. One is you simply open a window when you're using the range hood. The second one is we have to install another fan ducted system that you turn on or that turns on whenever you run the range hood.
Right, okay.
Not uncommon. There's a few products on the market. There's one that's imported. I know a few people have imported them. But I don't know how easy they are to get. I'll try not to use there.
Oh, yeah.
So these go in, I think, just in front of or behind. So basically you need a range hood that's in a cupboard for this to work. And somehow they connect to your I don't know if there's a picture anywhere of how it works. Let's just download it. Anyway, that's the only one I'm aware of that's out of the box in Australia. Other people have made up their own ones using inline fans with baffles and all that sort of thing.
Yep.
And certainly something you could do is then connect it to your range hood, so when you turn one on, it turns the other on.
Okay, no worries. I just took a couple of screenshots of that, so I'll step it up and go from there.
Do you know if in terms of style, do you know what range hood you're planning on? Is it in the cupboard or exposed or?
In the cupboard, we've got it drawn as at the moment.
Yeah, I'll have to go back and have all the plans to make a call on that and then sit down with Anne-Marie.
Yeah, well, if you're in the cupboard, then one of these is probably a good idea.
Yeah.
And Mark, what's the difference between a make-up air system and if we've got some air conditioning down in that living room, kitchen space?
So air conditioning doesn't bring air in from outside.
Okay.
Air conditioning's on a closed loop.
Yeah, okay.
This is just a curiosity. This is your heating losses and heating gains. So, for example, 4 kilowatt hours is coming from, the body heat, cooking, etc.
Yeah.
4.4 from sun in wintertime. What have we got here? The greatest heat loss is for the walls, 7.5 kilowatts. So yeah, that's just a curiosity. If we've got problems passing, then we look at this to see where our problem is.
Okay.
They always have to balance, don't they, too?
Yes, they have to balance, yeah.
Be the same.
So this figure here, 1527 watts, 1.5 kilowatts. So in theory, that's how much heating you will need. So the smallest air conditioning unit.
Okay.
However, as we've been discussing, when we've got a multi-story house, it's not going to spread around. So we at least need a unit upstairs and downstairs.
Okay.
And look, because they're cheap, air conditioners tend to work better if you oversize them a bit.
Yeah.
You'd probably put a 5 kilowatt upstairs and downstairs.
Okay.
Unless you're going to put split systems in bedrooms, in which case you would just run 2.5s everywhere. I think that's the smallest.
Yeah, I don't think we're doing that. I'd rather the 2x5s.
Did you end up talking to Pat, Andrew?
No, I had to put it off. You reminded me again. I thought of it this morning. I've got to ring him.
Okay.
I did speak to him briefly. We couldn't organise the time then. That was late last week. And I had to get back to him this week to organise the time. Obviously, not going to happen this week though. It'll probably be next Monday, Tuesday. I'm going to aim for.
Pat's the guy Scott from DHUM suggested would help with the design of the aircon and just making sure that it works with the HRV mark.
Okay. When we look at the cooling unit, you can see it is more, 3.7 kilowatts. So yeah, we definitely need the 5s.
Okay.
Well, in theory, 2.5s would get you that, but yeah, I'd be going the 5s.
Yeah.
Hot water. We need to put in the length of the hot water pipes. We don't have that yet, so I've just put a 80 in as a guesstimate. That's the length from the hot water service to each tap. So if you've got 2 hot water taps in line, we measure twice, once to each tap.
Right, okay.
We've got 8 hot water taps in the building.
Sorry, I've done that. I haven't sent it to you, Mark.
Oh, okay, cool.
Send that.
Now, as far as I'm aware, we haven't chosen a hot water system yet. Is that correct?
That's correct.
Yep. Okay. So I'll jump ahead here. This is our heat pump tab. Since we always use heat pumps in passive houses, almost always. I've just used the default for the air conditioning unit. What I will need to do is get the actual units that we're installing, and it's really complicated, need to get all the test point data from them and enter that, and you can see it all over here. It's a nightmare. And they always, well, not always, they give it to you in a number of formats, and you've got to put all these formulas in, and the formula is different for each format. So same with the hot water heat pump. I've just got the default in at the moment. I'd be looking at using a Sandon or a Reclaim. They're the sort of best ones on the market.
For a Sandon or a
Reclaim.
Okay, yep.
They're the best. They're a separate heat pump to tank.
Yep.
Instead of combined.
Yep.
They're the quietest. They use CO2 as their gas, which is not nearly as nasty as the other refrigerant gases. And they will go down to about -5 or 6 or something. So they don't need an additional heating element for when it's too cold.
Okay.
They are the most expensive, of course, but you get what you pay for.
Yep.
In terms of air conditioners, whoever supplies you is probably going to have a favourite.
Yeah.
So I'm in a Facebook group called My Efficient Electric Home, which has a massive number of people, and you've got designers, you've got refrigeration mechanics, you've got electricians, you've got plumbers, you've got energy assessors, passive house designers, you name it.
Yep.
And what I've gleaned from that is the preferred ones in terms of quality and backup service seem to be the Mitsubishi or Mitsubishi Heavy Industries.
Yep.
They're 2 separate manufacturers.
Yeah, they are.
Daikin is often rated well. However, I have seen a few installers talk about backup service not being as good.
Yeah, I've also heard that about Dakin not being all that flash.
Yeah, so obviously something to discuss with your installer.
Yep.
So this tab we don't really use much. Oh, there's the lift. Where does that go? I haven't put the lift in.
Okay.
Because we don't have the details yet.
Yeah, sure.
So generally speaking, no, I'm on the wrong spot. So we used, so we've got default figures.
Mm-hmm.
So for example, there's a dryer here. It's got an electricity demand of 1 kilowatt. Do we have a heat pump dryer? No, we don't. That's interesting. I wonder why they don't have heat pump dryers. Anyway, your stove, your all that sort of thing, there's just default values. So unless you're having something out of the ordinary, we'll always use these default values.
Yep.
In your case, we will need to put the lift in. As you might have seen with that email, they don't have the data, but they pointed out some other way, some default value to use or something. So I'll talk to the certifier about that.
Okay.
And what else? Yeah, solar. We put all that in here when we get it. So each system relates to a different roof if there's more than one. So basically what I do is I put the roof in that it's on, and it'll automatically give us our deviation from north, etc. The angle, actually, no, it won't, because we've only got ceilings in there, not roofs, so I'll have to put that in manually. The information about it, the cells, the information about the inverter, etc. And then it'll work out, what it figures you'll actually generate.
Mm-hmm.
So we don't just put in 10 kilowatt system, we're generating 10 kilowatts. It's varied based on reality.
Is the like a Tesla battery in PHPP?
No.
They don't account for that, do they?
Don't account for batteries. To my knowledge, I'm pretty sure they don't. I think maybe that's... no, it wouldn't be in the PER. Yeah, I'll double check, but I'm pretty sure they're not.
Yeah, cool.
So yeah, so we're looking good. Is I would say these are going to go up by 1 to 1.5 kilowatts when we put our range hood in. And the PR, once we put the lift in, we'll get a bit worse, but then once we put our solar in, we'll get quite a bit better.
Yep.
At the moment, I've got we just PR passive house. I've got classic plus. Do we pass plus? I don't know until we get the solar in.
Okay.
Do you know about the different standards, Andrew?
4.
So there's 3 levels of passive house.
Yeah. Oh, okay. Yeah.
There's passive house classic, and they revolve around the PER. It's 60 kilowatt hours per meter squared per annum for passive house classic.
Yeah.
40 kilowatt hours per meter squared per annum for plus, and 30, I think, for premium. Premium is basically means you're generating more than you're using.
Okay.
So we're unlikely to meet that. We're probably likely to meet plus.
Okay. I think the only way you'd meet that premium is if I got a whopping great solar system, inverter system in.
Correct.
Which would counter that value we're getting already substantially. Like people love to go out and get 10 kilowatt systems for their houses, like for a 3 or 4 bedroom house. It's overkill. It really is overkill. That said, you go back 5-6 years ago, everybody was getting a 5 kilowatt system and it wasn't enough.
Yeah.
Yeah. It's about 7. I'm looking at putting a 7.5 kilowatt system in.
You reckon that's enough?
I reckon it'll be enough.
So that will cover your winter generation?
Yeah.
Sorry, not winter generation, winter use.
Well, that's something I've got to look at a bit further.
Yeah. I'd be interested to see what your answer is.
Yeah, okay.
Again, on this group, everyone seems, there's a lot of solar installers on there, seem to say, base it on your winter usage, basically.
Bear in mind that winter generation is very efficient.
Because the panels are cooler.
Yes, that's right. A lot of people fall into the trap of not thinking that, but it is very efficient in winter. Yeah.
Yeah, I guess it comes down to the slope panels are on as well.
Yeah,
so.
You just don't have the biggest window.
Yes, that's right. Yeah. So, yeah. That's about all I've got to show you. If you've got any questions.
Not at the moment. I probably will have more questions when I play the video back. And
I can't send you this, Andrew, because it's paid for software.
Yeah, fair enough. I understand that. Yeah.
Yeah. Now, the next stage, as far as I'm concerned, is I will send this to a passive house certifier and get you a price.
Yeah.
Around $5,000. The whole process is what they seem to be running it at the moment.
Yeah, sure. Okay.
That's broken up into three sections. There's the initial review,
Yep.
pre-construction review,
Yep.
and then post-construction review.
Oh, okay. Right. Okay. We go
So
first.
what we're ready for is the initial review.
Okay. Yep.
For the initial review, we're fine to use some of these default settings.
Yep.
For pre-construction, we need to have nailed down all the components we're using.
Okay. Yep.
I try and get the initial review as complete as possible. But if we don't have AC units, that's fine.
Okay. All right. Well, I'll have something a bit more concrete next week.
Yeah, sure.
Yeah.
So I'll get a quote. I'm going to use Marcus Strang, who's an excellent certifier. Well, there's only 4 in Australia. There's not many to choose from.
Okay.
Two of them work for the same practice.
Yep.
They're all very good.
Yeah. Okay.
Marcus is a bit more timely.
Okay.
He works for a company called Hip V Hype in Melbourne, if you've ever heard of them.
Okay. Yep.
And he'll also give us a letter to submit with the DA.
Yes. So what happens is once he's done his initial review and he's happy with everything, he will give us a letter that says if this house is built as per this PHPP, then it will pass passive house. And then that meets our energy requirements for our BASIC certificate.
Okay.
Which we need for DA. So yeah, I might have a bit of tinkering to do once his review comes back, particularly with those thermal bridges.
Okay. Yep.
So yeah, but I'll just have to run this again anyway. If we're taking that wall out, so yeah, if there's any other changes, Corey, let me know before I do that.
Yep.
Can I have you got the mental energy, Andrew, to just look at 1 or 2 things in the plans?
Yeah, sure.
I'll stop sharing.
I know I'm struggling a bit, but yeah.
Not that one. Where'd you go? Come on, Robert. Let me try it again.
You're feeling the cold there, mate.
Yeah.
I'm in Wentworth Falls and I'm in a t-shirt. But I've got hydronic central heating. So.
Why is it doing this?
Would have almost been snowing there last night, you'd think.
It wasn't as cold as it has been. But,
Okay.
we actually haven't copped the weather up here as much as down
Yes,
there. The lower mountains
some people
copped
were
a big
saying
time.
some people were saying it was there was a lot of problems in the lower mountains. I thought,
Yeah, it was. I think
further.
it was coastal and it sort of stretched into the lower mountains. It was certainly raining and we had some wind, but yeah, not nearly as bad.
Well, we didn't get that much rain here at Emu yesterday. We got a lot more at Bankstown at work. It absolutely pelted down there most of the day. But then I got home here in the afternoon and I noticed, hang on, it hasn't really been raining that heavy. I can tell when it's been heavy rain because the tiled area just to the out the back gets inundated. And it was pretty dry. So, and at about 6 o'clock last night, I read that Emu only got 25 mil of rain from about 9 o'clock in the morning, which is
interesting how varied it is because we got more than that.
Yeah. Oh, we got a lot more last night though.
Oh, okay.
So one thing that I was just looking at previously we had the curve section in here in the store, so I was just straightening that up. I think it's still fine. It's 2.4 meters wide, and you got the triple height space in there, so it won't be too noticeable. Previously, also this wall here, I had it as block with stud to the garage.
Yep.
But thinking about it, I just thought it doesn't really make sense. So we got double brick out here, and then we got brick to stud over here. So I've just changed it to brick, so it's the same internally all the way around there.
Yeah, fine. Yeah.
And then
Does
the
that
other thing,
relate to any of the building envelope
no,
walls?
it's underneath.
So all the building envelope is the 140 style, is that correct?
Yeah.
Good.
Yeah. And then in here, in this section behind that wall, previously I had it backfilled against this wall.
Yeah.
But just thinking about it, in terms of longevity of your building,
Yeah.
keeping moisture away from there
Yeah.
would be better to over excavate a bit to be able to keep that water off that wall.
Okay. How wide we going there? I can't quite. There's no dimension on the width there. Oh, there it is. Okay.
About a meter or so.
That's all right.
So
I could have read that off the door, actually. But yeah, anyway. Yeah.
Yeah. So then have a door off the garage so you can do stuff in there.
Oh, yeah?
And
Yeah,
then
I think that's a great idea.
I think it's a good idea just to keep water off that wall.
Yeah, all right. Yeah.
I've got a water leak with an internal wall like that, and yeah, in all my projects now, I do what Corey suggested there.
Okay.
Nothing's really changed through here. I've assigned the dehumidification unit on this side of the laundry and the HRV over here. And I've had a look at I've imported all the runs from Scott in the ceiling plan, which is hiding from me right now. But the basic idea is on this one that you don't need to see all the joists. So the dehum and HRV sit in the laundry. This orange one is your supply from the HRV. So it runs around this bulkhead around there and supplies on that side.
Yep.
And then the brown one is the extraction. So you need to extract in the kitchen, in the laundry, in the toilet, in the walk-in pantry.
Yeah, yeah. Okay. Yep.
And the dehumidification unit will have a point either end of the living room. And that's, I think that's 200 or 180 through there. If I just go to this section, it shows the detailed section. Where is it hiding? Yeah, so this is the detail through that area. The 200 diameter dehumidification ducting can fit in there, and also the HRV, which is about 160 diameter.
Okay.
And I have like a featured timber on the
Is
bottom.
that the laundry?
Yeah, fair enough. Yep, that's good.
Is that the laundry?
The living room.
Yeah.
So the HRV is not 160. It's only 160 between the unit and the exterior.
Okay.
So the rest of it is probably going to be 90.
Okay, good. So yeah, if we go back here, so this yellowy thing that I've just highlighted now, that's the lower timber ceiling around that bulkhead.
Yep.
And then it's got a higher ceiling in here where your fans are and lights and feature lights over your island and that sort of thing is.
Okay.
With the AC, when you talk to Pat, I've put some indicatives locations of here and here.
Yeah.
So instead of having it, because your TV's over here, you don't really want your AC blowing on your faces.
Fair enough. Yep.
I've put it over there.
Yep.
So you've got two units there, Corey. You can get away with one.
Yeah, okay. I think we were looking at doing two. Yeah, we could do one. Yeah, okay. And then upstairs, just in the master bedroom, having it above this cupboard in that wall. And then the orange again, that's the HRV coming up from below with
Yep.
supply into the bedrooms, the orange ones, and then extraction from the ensuite and the bathroom.
Yep.
And then this is the dehumidification in the corridor here.
I like your little arrow things.
Oh, these bad boys.
Yeah.
Yeah. So that's the basic idea of it, and then I just noted I'm gonna have to just double check for the range hood here. We're gonna have to get some ducting through this ceiling
We are, yeah.
outside here as well. But I'll just give you the overall idea of the ventilation setup that he's given us.
Yeah.
Just
If we go for the range wood, do we just duct it out towards that beyond that
in this direction down here.
Yeah, duct it out towards there.
Yeah,
Through the ceiling.
it's possible. It's just we've got a fair bit of HRV ducting going on.
Yeah, that was my concern. Yeah.
I did a detail of that. So I've been working on a lot of the details. That's not what we want. Heaves, no. Oh yeah, this is that detail. So we've got the HRV ducts in that ceiling space.
Yeah.
Running to upstairs, and then the dehum ducts. So it's a bit tight. Just wanted to make sure we got enough room in there for everything.
Okay. Speaking of which, back a moment, about 2 or 3 minutes ago, you had a section shown through the dining area with 160 and the 200 duct in it.
Yeah. Okay, yeah.
Is that the outside diameter?
Yeah.
Assume it is.
Yeah.
Okay, so
the 160 should be 90.
This one should be 90.
Oh, that makes things a lot better then, I suppose.
So confirm that with the with Scott, but I'm pretty sure that it will be 90.
All right. Is there any issue with them with the proximity to each other?
Oh, there you go, 75. It's even less.
Okay.
Is it 75? Sorry.
Just go up a bit there.
Oh, this one.
Yep, I can see that.
And this is the one to outside? Is it the 160?
Should be, yeah.
Okay. So does that include the insulation on it, Mark?
So the internal ductwork won't have insulation.
Okay. So what sort of separation you can have between the two? 50 mil, 70 mil, 100?
Say that again.
What sort of separation you're going to have between those ducts?
Oh.
You can't have a button against each other.
Yeah, okay. In general, what have we got?
Corey, you've got service cavity insulation too, which is not required.
Yeah. So I was thinking the 200's got to be offset a bit further to the left as I'm looking at it now.
Yeah.
Okay. But we've got away with that with the 75 being there, not the 160.
Yeah.
And maintain some separation. That's all there. Yeah. Okay.
And you're saying, Mark, we don't need this insulation?
No, I haven't calculated with that. So.
Okay.
Save some money.
Yeah. Okay.
This is all coming to light because I'm designing a high voltage system for a huge data center at the moment, and we're having an absolute shit fight trying to fit how many high voltage cables in conduits they want and maintain separation of them so that they don't derate by stupid amounts.
I'll have a chat to Scott. Separation of dehum. Do you happen to know, Mark? How far they need to be separated?
No.
I would say 70, maybe 100. No, wouldn't even be that. Wouldn't it? But it'd be 50 as a minimum.
Yeah. We've also
it's a standard practice to do that because of the bell mouths on the duct if you're going to have longer runs on it. That's all.
Okay.
Hmm.
The eave detail. I've been working on this one too, as we've changed it to a raised heel truss. I'm not sure if that's exactly how you draw it, Mark, but it's
Yeah, that looks pretty close, but yeah, as long as you've calculated it for the insulation, I've said the R2 and the R4.
yeah.
So the R4 ceiling insulation is deeper than R4 wall. I think it's about 195 or something.
Okay. Yeah, I'll have a check. At the moment, I've got it as 275 R6, so I'll double check the.
270, 195, 295. You might be a little bit short.
Okay.
And then, yes, you need your ventilation pathway above it.
Yep.
Again, you've got your surface cavity insulation there.
And this is 75. So this is your ceiling with a rondo system, and then the truss is up here, and the airtight membrane is fixed to the underside of the truss. And to try and maintain the longevity of your wall, we make sure that there's air venting behind the cladding as well. So we've got stainless steel ember mesh at the top of the cladding and a 25mm gap. And then in the eave gutter, we use a similar sort of product there to get the ventilation through the mesh.
Or you don't have vertical battens in there, in the wall.
Don't have vertical battens.
So you need vertical battens on top of your membrane on the outside cavity.
Oh, yeah.
So otherwise you won't have your airflow.
Do not run horizontally. I've got that in the note. I've just got it as a description in there. Just
Okay.
so you can see it. But yeah. So that's just bumped the roof up a little bit in terms of thickness. But now that this is 75, we might be able to regain some of that height. Because
No, because you got your 200 for your dehumidification.
For which one? Dehumidification.
The dehumidification's setting at 200.
And his only in the in that corridor, I think. Just this one here in the corridor.
Oh, okay.
So he'll run from here to there. So we could possibly have a lower ceiling in this area.
Lower or higher?
Lower. This pink one's going to be 200mm, you're saying?
Mm.
And these ones 75. So I might have to lower, or maybe I can raise some of these. Well, not what I've got an issue with is the building height for DA. Because of the raised heel truss increasing the roof height. I want to make sure that we don't break the LEP 8.5 building height. So if I can reduce the roof height, it might be okay. Okay.
So is that 2.6 to the ceiling, including a 200mm cavity, or?
Yeah, on 200 on top. Yeah.
Yeah.
So, sorry, Andrew.
That's all right. I was agreeing with that. 2600.
And
I remember going through it with you.
Yeah, I've been having a look at just to make sure that the position of the windows and doors and structurally everything kind of works well as it can. So I've put in all the joists and beams. So there's going to be two main steel beams from the previous structural design with these columns here and here, column here and here, and then the joists spanning between there.
So what are those columns made out of, Corey?
Steel.
So you've got a steel column in the building envelope.
Yeah.
That's a problem.
Yeah. So we had 8 beams in there before. So we've got 2 now. That's nice. We're reducing it.
Yeah.
But trying to look at how we can fix that. Any suggestions, Mark?
Well, you'll either use timber if you can, timber posts, or can we move the beams in, the posts in, or do we need posts there? Can they just sit on the top plate or hang off the wall, or just because the engineer's drawn it doesn't mean it can only be that way?
Yeah. SC1, SHS, and its SB1 is a 250 UC. So I'm not sure. He might. I'll talk to him. I've reached out to them to give us a quote to upgrade the plans, Andrew, because we need to sort of start looking at some of these things. If we can change that to timber and timber and timber and timber, that'll be good. So we had all these other beams in before that we can get rid of most of them.
So if the two beams can't be supported by the timber frame wall,
yeah,
but 4 beams or whatever can be, then I don't see much choice. I think you're going to have to go with more beams.
Yeah, so the reason we changed the reduction in beams was because we had this step out in the wall that was all open. So to simplify the building form, I removed that step out and the wall just continues straight through, and I removed this step out and the wall just continues straight through.
Okay. Yeah.
So it's got rid of those beams there, and what we might need to do is, if they can't be timber, just bring them inside the thermal envelope.
What size are those columns in the engineer's drawings?
90 by 90.
So if you're going to bring it inside, you've got 45, 55, we'll call it 55, 60. So you'd have 35 mils protruding into the, no more, because you'd have to plaster over it.
So we could look at doing slightly thicker surface cavity, or just have localized thickenings, I guess.
The other thing then too is you're blocking your surface cavity.
Yeah.
I tend to think you should be able to put a few more studs in there and have the beams hang off that. But the other thing to look at is potentially using LVLs instead of steel.
I think the span's too big, it's about 3.5. And the other problem, I think why it was a problem in the past is because we've got a big tube of that living room, there's not much bracing happening. And so I think that's why you wanted steel in there previously, to help brace, because we've got a big opening either end and it's all hollow. So that's a little bit why I've included these bracing walls at each side of the wine cabinet to help give some rigidity to it. The upshot, Andrew, is we need to talk to the engineer and try and figure out some of these details.
Okay, all right.
So I'll need all this sorted before ideally need it before I submit to the certifier.
Yeah.
Okay.
And what else did I want to talk to you about? I think they were the main ones, just giving a bit of an update of where things are up to.
Yep.
Yeah. We've done. Yeah, I've got some other drawings to send Mark. These ones, some hot water ones and stuff. All right. Thanks for that.
Are you done, Corey?
Yeah.
Can I share my screen again? You got it?
Not yet.
Oh, okay. forgetting to hit the share button with Zoom. So that here, this wall is pushing into here. Is that right?
That's right.
See if I can do that. Delete that one. Delete that one. Delete that one. Oh, Jesus. What's here? Okay. Say that as I never save over a file in case I break it. All right, I'll fix that up.
Cool. Thanks, guys. I'll follow up with the engineer and some of those changes to the drawings and send you the drawings, Mark, when I've got stuff sorted.
Yep. And I'll get a quote from Marcus.
And you'll get a quote from Marcus, yep.
And I've got to follow up the hot water service, the AC, and the range hood.
Yep.
Right.
Yeah, I mean, if we can get them soon, then I will put them in. And we're stepping into the pre-construction section, but that's not a problem.
Yeah, okay.
The more we know up front, the better.
No, that's fair enough. Yeah, okay. Yeah. I'll aim to get that. I'll say Thursday next week. Give me time to work with this AC guy next week.
Cool.
Yep. All right.
All right.
Thank you, gentlemen.
Hope you feel better soon, Andrew.
All right. Good stuff. Thanks, guys.
Okay. See you
later.
Bye.